Righty-o. Amazing. Oh, my laptop battery died. No, the Wi-Fi connected. That's not fun. My chat's not coming up. Ah, here we go. Good. Lovely. Lovely. Right, the titles are right there. Making sure the titles are all good. Oh, yeah, they are. Nice. Cool. So, welcome everyone. Hope we're all doing good. Hope everyone's had a good Friday. So last night, we were working on adding moss, right? We want to try and have multiple layers of materials. So I thought it'd be super cool if we have brick. So why don't we have moss? So we can add a moss layer to the brick. That would be cool. So our materials are 3D, right? They're ray marched into. So we've just drawn some boxes and we're ray marching into the boxes. And if we miss everything, it will basically not render that mesh and then try and render the mesh behind it. We've got some order independent transparency as well. We've still got to get the, we've currently got alpha discard working, but half transparent stuff is just a little bit of tweaks to the code and it'll work. It's not going to take anything too big, but we'll add that later. So the plan is today is to add detail to this. So we've got a nice blobby looking thing, and we can tweak it to probably make it look better, but all it is a bunch of spheres which have just been kind of made into some kind of ellipsoids by scaling them out a bit, and the spheres are laid across a grid at a certain size, and then we take another grid with bigger spheres and less entries in the grid, if you will. And so we just have layers of these grids, which are not necessarily like multiples of 2, but like 1.3 whatever, just some random number, such that you don't see patterns form. And then we're taking a smooth union of all those grids and creating this shape, and we're just ray marching against it. So, sign distance fields are super cool, but obviously they do come at a bit of a cost. I'm going to try and optimize it later. We've got some plans. We just want to get the features in first. But yeah, so we're going to add some detail today. We're going to make these. We're going to go into this moss, if you will. That's the plan. Got some ideas. Let's do a quick prayer first. Right, dear Lord, thank you for this day. We bless your holy name. Thank you for being our great provider. Thank you, Lord, for giving us everything that we have: breath in our lungs, the home, the warm home, food that we have on our table, fuel we have in our cars themselves, our wives, our children, the peaceful neighborhood that we live in. Thank you, Lord, for all these things, because not everyone in the world has these things. Help us have a good day today, Lord. Help it be a successful day. Help us work on stuff which is ultimately going to yield fruit. And, just pray for everyone else in the stream that they get to know you, Lord God, and receive the truth, and receive the way, the truth, the life, which is Jesus Christ. And we pray, Lord, that each and every one of these souls and their family souls be saved, so they don't end up being eternal separation from you. Instead, they'll be eternally with you in love, in peace, in bliss for eternity. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, again, it's just a bunch of spheres that we smooth union. Now, there's sign distance functions, right? So they just give you a distance to the edge of an object. In assigned one, so negative means you're inside, positive means you're outside. So you just keep marching along a ray at that distance until you basically get super close. Now, Oh, did he change his website, for crying out loud? Right, so we're looking at gradients. So what is a gradient? Then the gradient of an SDF is very useful. The gradient for an SDF at any point always is a length of 1, since the FDS measures distances. So it's normal to this. So it's also a normal to the ISO surface passing through that point. This gradient also points the direction of the closest point, and as a normal is useful for lighting, aligning objects to ISO surface, etc. Of course, one can use central differences to compute gradients. That's by basically sampling a few times the scene, and then you get, you take things away and you basically end up, you kind of make them, you sample different offsets and you put those into like a vector and normalize it sort of thing and take differences. That's what that means basically. But that has a high computational cost of 4 or 6 taps. Yeah, we do the 4 tap version of the scene. Yeah, 4 samples, which can get quite expensive. So effectively, a gradient is basically like a surface normal. So these are modified versions of the SDF function to return not just a distance, but also a normal. So what we could do is get the normal of the sphere, and then probably we've got a bunch of spheres being smooth unioned. So maybe yeah, so I wonder if we could get the normal of the surface basically. Yeah, it's a bit expensive at the moment, but we'll sort that out. Right, so graphics materials, let's find the MOS distance. Distance MOS. Right, here's our boy. So it's kind of like a fractal Brownian motion in a way, right? It's got a couple of parameters, like a initial spacing and smoothness, and we've got different grids. And every time we visit the different grids, we increase the spacing just by some random number, yeah? Now, and then we do a smooth union of all of those spheres, a grid of spheres, right? Cool. Now, so if we just did a union, it'll look something like this. Right, see, it's just a bunch of ellipsoids, basically, and we just smooth union them. Now, what we kind of want to do is probably get, if we got a normal out of this, so if we did with a gradient, so it gives you a normal back, maybe we could slurp. I think you'd need an S slurp, right? A slurp to interpolate a normal. So you got AB, how does this work? A take B. So K is K, what is, so H, oh, there's a K in here as well. Yeah, it's just kind of like a distance about how much to, right, I wonder, Hmm. Yeah, I wonder if there's a way to also smooth union a gradient. Yeah. Because, like, effectively, if you've got a. The problem is these are just that's a sphere and that's another, like, ellipsoid there. And this bridge bit here, it will be made because of the smooth union. So, ideally, you want the normal, which goes upwards, right? But, I don't want to have to sample the scene like 4 times to get that normal. Because if we had the normal, then we could basically create that sort of like hair. Oh, did I even post it with live? Whoopsie. So some moss. You kind of, if you had the direction, it's quite a nice one, isn't it? Yeah, if you had the direction of the surface, that could be quite handy. Right. Let's try before the smooth union and see what happens. Alright. So, if we had the gradient version of the... It's great that there's done so many of these. SDF 3DG. SDFG. Position local space. And we need an R for radius. Alright, here we go. So I reckon... So the distance would be in X, the normal will be in Y. W. Alright. So the plan would be I guess let's call it G. So we should want a D, which would be G dot X. We get the normal, which would be G dot Y Z W. So that all still works. Now I think the plan. So now I have the normal. I wonder what we could do now basically. Could we remove the distance? Nope. I wonder if we can shrink the distance based on the normal. Say we did 0.01. That would just shrink, right? Hang on. Now you got to do a length in it. Wait. The length is... Oh yeah, of course. You can't shrink it. Yeah, I wonder if that's what we need to... So maybe we don't need a normal. Because there's distance, all we need to do is just shrink it. And it's a sphere, right? Yeah. Interesting. So maybe... Alright, we'll keep this anyway. Keep the... Yeah, maybe... So you could probably do it at the end. So you can add like... So you can just find the sphere surface, and then once you get there, you can just reduce the distance. Well, it might be good to have the gradient anyway, though, as an input. Or maybe based on the position. The UV. Mm. No, because... Yeah. Right, so I reckon you can do a normal as input. We could say hash 3D based on a normal. I think I get 0 to 1, so we do. $707. Right, what have we done? So I think this is too noisy. Let's increase the frequency a bit. Yeah, I wonder if I have to use the value noise. It's really expensive though. Oh, we're sort of getting something there. Although it's had a lot of performance. Put up the texture viewer. So reduce the frequency a bit, I think. Yeah, so if this is going to increase like the depth of it, right? Oh, interesting. This is cool. Right, minus though would make it go inward more. So this makes it extrude, whereas that makes it go less. Okay. So maybe what we're looking to do is extrude, actually. Oh, not extrude. Is that the right word? Yeah, so grow, basically, yeah. You make it shrink. Or we can make it go in place. No, the normal is very handy though. So I wonder, right, if this will be the sort of what do you call it, the mossiness, no, the how deep, call it the deepness. You always got to make it a ness of something. So this is the deepness parameter, which we've got to pass in somewhere. So I reckon if you take the deepness from the radius as well, so take away deepness, or add deepness. Hmm. Oh wow. Spacing is 0.21. We're able to take them more away. Yes, you want to find a max. So deepness will be deepness will be, you want to pick the minimum between deepness and radius, and then you want to basically do radius take away equal to deepness. Think. Or is it max? Pick a max. No, that's wrong, surely. Um, right, why 0.5 though? Yeah, so what we're trying to do basically is change the radius such that when we change the deepness, it doesn't make the spheres grow. Instead, it makes them and it doesn't make them shrink. It just makes them go deeper and stay in place. That's what we're trying to do. So we're trying to shrink the sphere, and then after we've got the sign distance of the sphere, we just make it grow. Right, so that's all we're doing. Hmm. Right. So if we have a sphere that has a spacing of 0.21 and times that 0.2, that's how that's the radius. We have a deepness. Yeah, I don't know why we tried to. We can't go less than that. So also a scale as well, isn't there? Yes, the deepness can probably go. Right, so we didn't get rid of that. Okay, so if deepness is 0, that's what they look like. Right, as you increase. Oh, for crying out loud. Okay, your deepness can probably be 0 to 1. And 1, yeah, so 1 would mean as deep as it goes, 2 would mean, sorry, 0 would mean no deepness, right? So if we did 1 deepness, you're basically trying to reduce it down probably to about radius 0.2 or something like that. So your deepness so you have a deepness scale, if you will, you call it. So you want to convert the other way around, times 0.8 plus 0.2. So something like times 0.8 then plus 0.2, so 0.2 to 1, yeah? So then you're just going to say, right, times equal deepness scale. That'll be up here. Now deepness scale. Cool, so that didn't seem to work. Right, we're starting to see something. So maybe the scale needs to be applied different to the radius. You're applying the scale to say shrink the radius. And then yeah. And then later on that distance that gets applied is based on a normal, and that normal is first value 0 to 1, isn't it? So I think you just want to multiply it by radius, right? Which is a full 1 unit. Or the original radius. Boom. Cool. So I think we can bring that down. Okay, so if we have a deepness of 0, is that going to look like it's in place? Oh, something's off in it. Yeah, how do we make it such that... Yes, this is always being applied now. If you times it by deepness saying how much is it going to be applied? Maybe. Right, so if we turn it on, does it... Yeah, so you see how it just gets... Is it inset or... No, it doesn't shrink, but it kind of stays in place, I guess. It grows a little bit. I think. I don't know if it's good though. Right, so what we're going to do is do a lovely sine g time. GPU.time, I think it is. No, I think it's just time. Then times 0.5 plus 0.5, right? Because sine is minus 1 to 1. We want to go from 0 to 1. Right, so here's it animating. Let's get the texture viewer up and give it a bit of a review. It's looking a bit spiky. But these bridge areas, it seems to also shrink away. But it must be based on the frequency. So reduce that a bit. Maybe going up to 1 deepness is not right. Maybe we've got to redefine what 1 means. Maybe 1 stops at a certain point. And also you've got to remember the colouring as well. It's colouring based on the normal that it gets. Might be worth as we get a bit closer, to be honest, but... Let's see if the maths checks out. So deepness scale is like how much I can shrink the radius. So that'll shrink the radius of the sphere. And if we didn't shrink the radius of the sphere, then it will kind of grow, right? It grows outwards. Maybe that's okay. Let's go a bit closer to this edge, this side. Although by doing that, it sort of is creating problems. Yeah, so maybe what you want is a times by Yeah, so if we times by the inverse of that, so 1 take deepness, right? That would be, though I mean that when deepness is on, the radius will basically be 0, which is not what you want, right? But it's kind of what you want, maybe just adjust it a bit. Then if it's deepness is 1, then it's going to be doing the most increase. Yeah, I think that's what you want to set. So deepness scale should go. Oh no. Right, but then if you had 0.5, you're shrinking it by 0.5, and at most it'll be 0.5 of that. Yeah, I think that's right. What we want is, I see now. So what we would actually like, one take would be for this one. But you want it to be between 0.2 probably to 1. Whereas this one you want it to be from 0 to 8. Yeah, it's 0.8. Yeah, so I think we're just gonna have to make 2 values. So you get yourself your deepness, whatever that is. Now you can have your deepness 0 and 1, I guess we'll call it. I don't know what to call it, but there we go. Names are hard. So it'd be 1 take. It's basically this one here, right? So 1 take. Then probably, yeah, maybe that. Now your deepness 1, which is used later on, is just going to be deepness times 0.7. Nice. So multiply by deepness 1 here when it shrinks it. I could just call it deepness shrink and grow. That's probably a better name. So you're going to shrink here. And this is used for growing. Yeah, I think this is maybe what we want. No, because it's getting rid of the bridges. Right, so maybe no shrink. Right, so that's interesting. I wonder if what happens if we do a simplex noise. It's going to be far more expensive, but I just wonder what it will look like. Right, I think this is because it's in like a weird space. I think it's like in sort of pi times 2 space. It's like super weird. I think it's more than that. Bit too high. It's like far, far slower. We don't want to be using this, but I just want to see the looks that we can get. Yeah, it seems like okay. Yeah, so it does sort of grow, actually. That's the other problem doing it this way, is it does grow outside, so you can't do do a cheap step to the sphere and then do a more expensive step later on. Yeah, I think we can do something like this, basically. But obviously, it's so far too expensive. That's 16 milliseconds to do all that. So even then, this noise function is quite expensive, but I think it's manageable. I reckon there's an optimization you can do. So or maybe you can just use sine, but then again, it's already kind of zero. It's already it's already 0 to 1. So maybe what you're looking at doing is like just multiplying it. What's going on here? Um, I wonder. What other signs did we do in the other one? It's a sine. Okay. So we could do like a min element type thing. Right, no, it's not quite what we want. What about a max? So we have a product elements as well, so we can add all the signs up. I think that's just, or multiply them all. Alright, that's cheaper than the other noise. Just needs to increase the frequency maybe. Ooh. It's looking, you know, you're getting sort of evenness in a way, which I think you're kind of looking for. But it looks a bit spiky. Does he eventually look a bit spiky though? Right, let's get in there a bit. It's a little bit cheaper, I guess. So we're looking at probably making it go brown on the inside, then green on top. But then again, with moss, you sometimes don't see the brown on the inside. Right, I can look like this. You might see patches of brown. This is sort of it already. I reckon it's just a little bit too deep though. So if then on the... Yeah. So I think if you up the frequency and... Yeah, it can also have quite deep looking bits though, like... So you could have, you know what you could do? Will be more expensive though, you can have another... Yeah, signs are interesting. So you could merge one with another frequency. And that could produce something a bit more uneven. Right, let's try a 32er. Bit too high, I think, there. What if it was just 32 by itself? Yeah, 32 is a bit too much, maybe. I guess it all depends on camera distance as well with some of this stuff. Hmm. Right, I think we can stick with a 16. The sign is an option, it is a bit of a cheaper one. The other one was that noise, like a value noise. It's more expensive. So we're in scene shade, we're looking at a bit bumpy though. Okay, so so if we're just changing it based on the normal, could we pass the normals out? And then somehow yes, the other thing we could do is pass the normals out and then maybe merge them. Right, maybe add, normalize. And then run the noise function. And that would be cheaper. Rather than 3 times per step, it's running it once. So I wonder if this could work. So vec4, right. Now we want to store in here the normals. Yes, this will be the overall normal. So we'll do n equals 0. So I reckon we just do n plus equal g dot y zw. Then we just say normal equals normalize of n. Now the issue is you have radius. We're missing. Maybe get rid of that. We don't really have a min radius. Well, it's spacing in it. It's spacing times 0.2. So the radius could be maybe try that. Okay, how does this look instead? So on the merges, that's where it's important to take a look at. So it seems like it's stretched along the merges. I don't know if it's helped too much with performance. Maybe it has. But yeah, it just looks a bit weird. Hey, Duke of Cool. Stream imagery, is it looking very glitchy? Yeah, it looks completely different actually because of the HDR. Yeah, you're getting these are these glitch these here. Oh, yeah, those the artifacts, the aliasing, where it's like fizzing. So I see that too. That's because it's like probably too small, right? It's too high frequency for the camera distance we're at. Imagine when we zoom out, we've got to adjust, which might be a bit of a bugger, but we've got to adjust the materials based on that camera distance. And I imagine the further they are away, the less expensive it will ultimately become. But yeah, stuff I've got to play about with. Yeah, it's looking good. Definitely progress. Yeah, I don't think we have to try and set. No, I want to. That doesn't have to be perfect. Where I can come over and do second passes of these materials. I'm just looking to see like what is the best I can sort of come up with right now. But ultimately we just need something, right? So we can layer on top of the brick. I'm just trying to find the shape that I'm happy with. I think I'm kind of happy with this shape. Maybe we can just color it. Although it's looking a bit... So like this sort of moss, I think it's basically that, right? We just got to get the colors right. You know, have some browns in there. But then like this sort of moss, it's not looking like that, right? It's looking quite even. So I think from a certain distance it's fine. But as soon as you get in a bit close, maybe not. But I wonder how much you want to make it look right, you know? Um, Again, it's all based on like camera distance, some of this stuff, which we won't really be having to worry about until we actually like, you know, able to place meshes down and do stuff like that. So that can come later. But you know, we can sort of look like this, right? I reckon we're sort of getting there with that. Like it's shading the lighting information in there because we do the normal calculation. But the colors, like we can change the greens maybe. You know, have some different colors like a brown in there and what else? And some of these white things. So on the brick, we basically have different depths, how close you are to the brick and how close you are to the border, and that's how we do the coloring. So I wonder if there's a thing we can do and say, you know, how close are you to the you know, we can shade the top screen and the inner bits darker, but that won't be like mosses though, really. Maybe. Oh no, it is kind of what that moss is. Now I wonder also if there's a way to make it such that there's more ups than there is downs. Like this sign of normal is kind of making it such that um, yeah, so oh, this is also -1 to 1, isn't it? So that's another thing. So I think you can do so maybe can you power it or something like that? Um so Or it's the other way around, don't you? You want to do a pow. Maybe a one take. Maybe not. So product elements of a sine, and then so it's 0 to 1. You're multiplying them all together. You're going to still be a value between 0 and 1, but it's going to be more shrunk, right? So that means the ones which are the highest high, there'll be less of those. So maybe what we're actually looking for is that rather than doing a pow and all this, all I'm looking for is a one take. Oh, so this is where we're getting that structure. This looks weird now. This looks like, this object looks familiar. Is it like a sponge? Am I thinking like a sponge in my brain? That's weird. If I show this to my wife, I think I make her cringe. It's like holes and stuff. Funny. Right. Yeah, so it's like a grid. You're seeing the grid now. And rather than things poking up through the grid, they're poking down. Right. Okay. And that's because we're doing a sine. Do 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 do. Something we could have done is, since you're using the normal, right, we could pre-compute the noise. So since you're doing a normal, right, there's only so many directions in a normal. There's like a, we could pre-compute the noise that we want, or maybe there's something else you can do. Right, let's go back to this one because this one was better. I think. Yeah, so I reckon that frequency value maybe change based on camera distance to the point where it won't even change anything, right? Um, yeah, based on camera distance, we probably want to reduce the amount of deepness that it goes, basically, I think. So this value here, what value is noise again? Yeah, it's -1 to 1. Mm-hmm. Mm. Yeah, I wonder if we should just start coloring it in now. Yeah, the fact that it grows means that, like, so when we move the camera distance away, that high frequency information, we want to sort of like dampen it, basically. Maybe. But you still want to keep. Yeah, you probably what you probably want to do is reduce the depth of it, but then somehow probably maintain, or maybe not maintain the color, take an average of the color. So overall, the surface will tint towards the average of the different colors that can be expressed through the deepness, basically. So the thing is about the deepness, though, is that it will grow the object instead of staying still. So I do think we should grow it based on, we should probably grow the radius. Yeah, we were shrinking it before, weren't we? But that will cause. That's going to shrink it, right? Cool. So whatever the maximum is radius and then times some kind of deepness. Times deepness plus deepness is 0 to 1, I think. No, 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 no. Hmm. Right, so you have your spheres, you want to probably, we're trying to take away the distance such that it's saying, hey, it's more. It's gonna grow it. If you plus it, it's gonna shrink it. Now, the maximum you can shrink it by would be the radius multiplied by deepness. That could be 0 to 1. So you probably want to add another one of these. You can probably just call this the sort of max deepness. And that might be so I think you're going to add the max deepness. Then shrink. They're still growing, I think. So do we times this by 0.5 or times it by 2, I think, maybe? I think that's it. There's more in place. That's going to make it grow more, isn't it? Yeah, so hang on a minute. If we didn't do anything, what would that do? Okay. Right, so the maximum deepness would actually be 1, would be times 0.8. That's the value we want. Then there we go. Hmm. Yeah, I wonder if that's just a bit of silly maths though. I think getting rid of, just making it such that the radius can be bigger, and just making it inset, probably the way to go. So radius times deepness times 0.8. Now, in terms of that max deepness, so how deep can it go? Now, part of the other problem is as well is this does a, I think this is -1 to 1. It might not be. It's a fract, isn't it? And then a bunch of mixing. No, it's 0 to 1 already. Cool. So that's all right. Yeah. So the other thing to think about now is, yeah, we definitely want to color it soonish. I just wonder if there's a way that we can optimize this, because Notice how it gets quite expensive. It goes all the way up to 9 milliseconds, all because we're calling this noise function. So we could try sine, but it looks a bit too uniform, right? And you need to probably call sine multiple times. So we could try that. Call in sine multiple times, combining the results in some fashion, and then producing that sort of noise, if you will. That's the thing we could do. We did something like this before. And then you basically just, maybe product. So sine. So you probably want sine to be between 0 and 1. And then you just say how much of that do you want to accept, accumulate it together, the vector 3. And then we could probably product them. It just combines them. And then, so that went all the way up to 0.9, I think. Sorry, it went up to 9 milliseconds, I think, in some ways. So, yeah. Right, it's definitely a lot stable, more cheaper. So I think we can just tweak these guys, basically, and, an 8's probably a bit too low. And they're probably a little bit too even as well, so you probably want to pick something where they're not clashing. You probably do like a 13, 15, and a 21. Because if you make them if the numbers are sort of related to each other in ways, you'll get patterns of the sign overlapping, right? So, interesting. So sums are interesting. We do products. Just got to scale them up a bit. A little bit too weak, that I think. You just got to accept more of these. Maybe do like looks kind of doesn't look as good, that one, does it? It's just an inline fractal Brownian motion, basically. But yeah, the other one was kind of looking nicer, but this one's more stable. I wonder if we're still a bit too high frequency. So the other one was 6 actually. So these are like very much higher numbers. So multiply by 6 at most. So maybe we should do a 3, a 6, and a 9, but then they're kind of related. So maybe we're looking at maybe a 2, a 7, and a 10. Get rid of a layer. Yeah, right. Let's just go back. Right, so right, let's just accept that. Always change the layers. So I guess how can we color this one in? Tweak these values a bit. Right, so how can we sort of color this? So we could decide on so without this deepness, if you will. Yeah, then it's but I think the question is you want to add like how deep is this as an output? So we should probably add another structure now. Distance moss out. You have your I think we did this for the brick, didn't we? Okay, so I think in this out structure, we're going to return maybe your, how deep is this thing? And the deeper it goes, the more brown it gets, maybe. Mm. The problem is it's like a smooth blend. There's different grids. So that would then mean, how do you blend that? Like, maybe... Alright, I got some ideas. So I think what we can do is like, you could pass out a distance, but then also a deepness, if you will. Even though there's a deepness parameter, but we can call it a D deepness, something like that. So your D deepness is going to be that. Then you're going to add it to here, and then also return it. So now I reckon if you D0, you D1. And I reckon you can just maintain 2 of these and then pass out in out.d deepness D1. Alright, so this should give us a value of like kind of how deep is it? I'm hoping. And then we can use that to color basically, right? You can already do AO maybe, but more than just that. Okay. So O 0, okay. Nice. Right, so let's just start off, right? What is this value? Is mouse at shading debug screen coordinate, print it out, o.d deepness, okay? So what is that? Let's see. So we're getting a bit of a minus value. Oh, that means it's inside, doesn't it? Cool. Now, your D... Trying to find, where is it getting super deep? That looks deep. Let's keep up there. Right, so it seems to be getting smaller. The larger it gets for some reason. Completely weird. So is it kind of the other way around than I'd hoped? So let's investigate why that is. Ah, we're using the wrong distance. Oh. Right, let's try this out. I'm not going to put the mouse over. Let's try the... It went positive for a second. Right, let's take a look at these guys. What's going on? Oh, it's the brick. Right, so here's the Right, so your deepness should kind of be positive, right? It's like... Right. Right, we'll be seeing 3 values per pixel. Right, can I pause it on a 1 deepness? Because this moving is just not really working. Alright, so we got G, then a hex number, it's either 1, 0, 1, or 2. So they're the iterations, right? So this looks pretty deep. Then if I'm... So that's about 0.12 to 0.16. Now move it to the peak. We got a 0 to a 0.014. Hmm. I think maybe I need to get a bit closer, to be honest. Right, that looks like a peak. The max value there is about 0.02. 0.025. 0.015. Yeah, so it seems like the valley has a higher value, which is what you want, right? So what do we change here, by the way? Do we change much? Yes, the valley had a higher value, something like that, and then it's done a smooth blend between it. So yes, I think the deepness value looks fine. But the problem is it's in deepness. What can we call it? I don't know. Right, so I think what you want to return is the noise, right? The 0 to 1 value. That's what you want to return. Because you want to say basically how deep is this thing? And you're combining it. So deepness would be that. This would be combined onto there. And then you'll be returning. Yeah, so now you got a 0 to 1 value. So if we get rid of that and reveal this one when it's all been combined together, the values are yeah, 0.3, that's looking all right. Oh, this all goes up quite high. So now let's try and use this as a way to color. I don't know if it's right, but let's make it AO. Right, that's changed something. It kind of changed the colors of everything. But right, can we flip that on and off, maybe with a bit of time? Can we intcast G time and then mod to it? Oh, hang on, I gotta do a thing. Right, so it's flipping AO on and off. Can we color the AO instead? So maybe instead, actually, what we're looking for is like, maybe you can set color and all of its RGBs. Right, it's a bit let's zoom in on that a bit. I don't think it's the raw color that's part of the issue. Can I turn off the normal shading? There's a normal shade somewhere in there. There's a... Well... Do we just want to return diffuse? Not really helpful, is it? Yes, it seems like the peaks. This is helpful. Well, it's kind of flashing some nonsense in there, but basically what we're seeing is, I think, deepness is the wrong way around. Thinking. Because black... I don't know, it looks a bit weird though. Yeah, there's some peaks here which are black, right? Peaks are black. Oh, I think that's right, isn't it? Yes, I think what we want is the other way around now. Yeah, that's right. So deep is deepness, right? So 1 would be the deepest valley. So your AO is 1 take deepness. The right, it's a bit better. Cool. So there's your AO map basically. So your AO is 1 take deepness. We should probably have ways to view AO and all this in like debug panels, but yeah, anyways. Right, so we get rid of that. then put it back. Cool. Right, so there's AO applied. That helps with something. The next thing is we need to color based on this, right? So I think what we want to do is find a nice moss picture and oh wow, those lovely stretched images. So yeah, I think we want to extract all the colors out of this moss. Yeah, I think you want to get some of the white. You want to probably get a green, a white, and a brown. And then we can basically pick between those. And I think that'll be it then. Yeah. We can improve on it later. Maybe there's ways we can make a furry surface with we'll see. Do 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 do. Right, let's just take this image and chuck into Creator or something. Doesn't have to be perfect, right? I just want some colors, you know. Where's Creator at? Great clipboard. Thank you. Lovely. All right, so we're looking for a green. You know, I guess it's obviously lit, isn't it? So you want to try and probably pick something a little bit in between. Plus, I'm not really using sRGB, so there's another thing. I'm not using Rec 709. Yeah, I think we want to have probably a dark green and a light green. But then again, the lighting's going to probably do that anyway, isn't it? So, yeah, I think the lighting's going to do that anyway. So why don't we pick more of a neutral color? Neutral green, if you will. I think that's kind of neutral. So can I get you in? Right. Oh, I didn't realize you could get that up so quick. Right, so we're like a 95. So we've got to kind of turn this into 255. Right, this is sRGB in it, so we can sort it out. So 0.372. So I'm going to go to P3 from Rec 709. I think that's the function. Yeah. So we can work out that. Just got to give it a run. So that will then be 127. That's basically 50% in it. So yeah, 498. Then final one is 13. Cool, so there's your color. Right, that did change, and that came out as like a greenish color for some reason. Is that, or yellow? That's what I meant to say, not greenish. We're looking for greenish, but it came out like yellow. Why? It's because of the crazy lighting, isn't it, maybe? Unknown name. What about the sun? Get sun radiance. This is like a yellow, isn't it? What happens if we had just a white? And then if we dropped... Yeah. Yeah, I wonder what the best way is to get some of these colors. You know, I'm just going to monkey around until the colors look right. But yeah, when we... The sun is natural light, right? So... Yeah, stuff to think about. But anyways, so... You know what, maybe we just got to eyeball it. So less red, more green. Kind of before, right? Cool. So we're also looking for maybe a... So green and like a brown. So a brown is more... It's like orangey, right? So it's like a red and a green, but then dark. So basically your color wants to be a lerp between the deepness. The deeper it is, the more brown it is. So green on the left, brown on the right, and then OD deepness. Oh. O dots. Cool. So you see it's a little bit, we're getting to some of them, although it's not, what is full, what does brown look like? Right, so clearly not the color we're looking for. Okay, so what we're trying to see is probably go a little bit darker. Right, so how do we get orange? Orange is, no, yellow and, that's yellow, isn't it? So you want a little bit more red. Right, so now you just need a dark version of that, basically. So if you divide that by 5, you divide this by 5, something like that. 2 green. Um, yeah, just something like that, yeah. So now we just merge. I don't know the maximum deepness it goes up to, really. So it's meant to go all the way to 1, but it is kind of merging between them. Maybe we need to take a max. Yeah, rather than a smooth. No, I think that's right. Yeah, at least it's brown on the bottom. I think we can live with that. Okay, so yeah, so it sort of looks like moss, I guess. So I guess we can just accept this as working all right. Performance could be better, but again, stuff we can tweak. So the main thing we want to try and do next is multi-layer materials, right? How do we get the brick? How do we get the moss on top of the brick? And only on top of the brick that yeah, and only on top of the brick surface, maybe. Maybe. Nah, I think you can merge them. So if you got 2 choices, right? So we're ray marching. So I've only got one layer at the moment. So we do the shade. the shade is going to call one of the shade functions, and that's going to do a ray march inside and then shift the UV along. Right, so the question is, maybe what we need to do is actually move out the ray marchers, make them completely separate from the shade, and then use the distance functions, right? And those need to have, like, this ray marching thing needs to go into a separate thing called maybe like um, ray march moss, right? And you do a ray march step before the shade that modifies the UV, and with that you can compute a custom normal as well. Then you can pass in all that information to the shade. But then the problem is you have with custom out properties. Also, okay. So that's one of my current issues with this is we have for the brick, when we do the distance of the brick, we have a distance brick out. Distance brick out has a distance to the brick and a distance to the border, such that when we color, we can use those to be like, hang on a minute, did we hit the brick or the border, and then shade accordingly, right? So I think what we're going to need is ways to pass from the ray marcher maybe a few different distance values. So I don't think we're going to need much else. I think we can generalize it. So you have a ray marching pass, and then you have a potential ray marching pass, and then that ray marching pass can pass a bunch of, up to 4 floats maybe we'll pick. So there's 4 registers that gets passed to the shading pass later on. Now we want to try and do some of this ray marching at lower resolutions, right? So that means the final high resolution, when it provides the hit, will provide the output parameters. So we don't really need to worry about storing those in textures anywhere per pixel. They just have to be recomputed in a full screen pass. So yeah, I think that's not going to get in the way of anything. That'd be pretty cool. And if we separate out the ray marching step, yeah, this can work. Right, so let's start by just separating out the ray marching step from the shade pass. The problem is though, is we're going to need it's going to need to decode the parameters a few times, which kind of sucks. But we're going to have to keep it separate anyway because of the low resolution needs to do it too. Okay. Yeah, I think we can do that. That'd be worth it. Man, that scene shade is expensive. But yeah, we're doing stuff at like quarter resolution, right? If a lot of expensive steps are done at quarter resolution, it should help out quite a bit, right? The plan. We'll do that later. Excuse me. So let's start with a brick. So brick. Do, 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 do. We'll call it Ray March. So the Ray March brick is just gonna effectively modify the UV. Okay. Now, Right, so these input parameters, we need to copy those. For when we do the shade pass, yeah? So how much of these do we actually need? So we need roundness, bumpiness, deepness. So let's separate them out. Yeah, so we need bumpiness, roundness, right? Cool. We don't need border color or brick color, any of that stuff, yeah? So we want brick, color edge, no. Offset, we need no glossiness, deepness, border dims, brick spacing, brick counts, right? So I don't know how many of those we need from here, but let's just read in all the words anyway, so it's less error prone. Cool. So the next thing is we need this world from material transform, because we're going to rotate the rays and go into material space from world space. We've got this sort of min hit t thing. I wonder if we can generalize some of this code, but yes, this brick half counts as vector 3. I think we need a generalized structure to pass this through. So we need some noise stuff, sampled material. I wonder this under PBR. So we're looking for a what is it called? So you want to pass like, hey, this was the ray marching. So pass stuff from the ray marcher to the shading pass, right? That's what you kind of want to do. Is pass from the ray marcher to the shading pass. Now I was thinking you probably want to get a t distance maybe. But then your world from material. But to be honest, that world from material should come out of here and be passed in as a transform. And you should probably pass in the material space parameter anyway. Yes, I think these guys, which would be super cool. You don't have to recompute that all the time. So, right, let's go to the more generalized function. So you calculate shading color, shade. So we probably want to have a ray march, if you will. Now the ray march yeah, we need to probably do different layers. We'll sort that out. We'll just sign the refactor first. So, the raw one doesn't need any ray marching, it's just a raw color. So we just break from that, I guess. Brick will need a ray march. Now I'm thinking, so you want to pass in a ray origin, which is the UV, I think. Shading UV. You want to pass in the ray direction. And then get a T. So it's good to pass in the shading strut regardless, I think. Debugging and stuff. It's got a bunch of stuff in there. We want to pass in probably the ray origin. So that would just be shading.uv. And then you probably want to have like a T value that gets returned. And so when you ray march, the value that we're storing out is a small in the depth in the future when we do those when we do those downsampled one, maybe it could just be a like an offset, like a depth offset, maybe a U16, and then maybe we can store another few things like what material index are you on, like layer maybe, or what object you're on, something like that maybe. All right, 2 seconds, BLB. Right, so if we're looking for a depth, yes, ultimately this ray march is meant to like for now at least just move the UV along and then compute a new UV and then use that, right? That's the plan. So yeah, I think that's all we need to worry about. And then obviously add multiple layers. So yeah. Okay, so we'll pass in a ray origin, material space, ray origin, array direction, material space. We'll do those. Now, if we so yeah, should we just do the multiple layers now? No, let's just do the refactor first and get it a small refactor, get it working. So it's separate ray march functions. Okay, so that's fine. So you want a ray march that will change your shading dot UV to be equal to ray origin. There'll be a T basically, right? What is the T? T is 0. There'll be a how far did you step basically along the ray. Then we'll do ray origin material space plus ray direction material space times T. Yep. Nice. So I guess you could probably just do plus equals there. Ta-da! Amazing. So we should probably do a ray march first. Like so. That modifies the UV. It reads out the material a couple of times, but oh well. We need some passing parameters now. That's the other thing. So we need a way to like go, oh, you've hit your. Oh, what's the problem with multiple layers now? If you add multiple layers and you do separate ray marching passes, are you saying that yes, we're not doing like an alpha blend of things. We're doing like a like so you're probably yeah, so let's draw this. So because I'm trying to picture it in my brain, but not very helpful for you guys. So you got your brick, right? You got your array. And like you shoot into the brick here. But then like also there's a moss material. So essentially what you one of the ways you can do it, so you got your moss material, whatever that looks like. So what you could do is be like, well, ray march against both of these layers and then take the minimum T. But then and then whichever layer you hit is then the one we will shade with, right? So that's one approach. The other is the other would be yeah, I think that's probably the best approach. Yeah, I think that's the best. Yeah, the problem is with that though. Hang on a minute. Yeah, but what happens if you just want to put? So does that mean all of your materials have to ray march to get a color though? Right. So I guess if your material is not a ray marching material, you can just sort of apply it on top of everything, maybe. Um. Oh, but what you could get is maybe some pixels would be where they both hit, and that would then mean nah, no, you'll get a closer one though. You'd always get a closer pixel. So do we have to ray march all the things to decide? Excuse me. Mm. So say if like you just built a mesh and you just wanted to make it like a metal, they don't really have too much of a thing to ray march against. Then you would just apply it. But then maybe you had a yes, I think there might be two different types of materials. Maybe I don't know. So if they're ray marchable materials, these ones you pick the best ones sorry, you ray march until you hit something, and then that's the material you color in. But if it's not a ray marchable material and you have layers of materials, then what you're probably looking at doing is blending that material. Like, say if for some reason you're like, right, I'm coloring this pixel, but the layers of materials we have is brick and we have a gold material, right? What do you do then? Or maybe you want to try and put gold, specks of gold in there for some reason. So what you could do is have a, so obviously it ray marches hits the brick. Now you're trying to shade. You shade the brick layer first, and then you're trying to shade the gold, and maybe you have a chance to sort of like, or it might be all right. Or another way of doing it would be your aim march against the brick. You hit that, and then your second material, you'll then maybe inside the moss. Then you try and ray march outwards. No, that's not really that great, is it? Well, maybe. Yeah, so that's another option, I guess, on the table. But then you got this gold problem, right? You've ray marched against the brick, hit the brick, you colored the brick. Now, you've got maybe a lovely gold material, but you don't necessarily want the gold to be applied everywhere over the brick, for instance. So maybe there could be some sort of noise. But then is that part of the gold material itself doing the shading and then be like, we can reject that here, right? Or so maybe there's like a then you sometimes just paint maybe a gold color on top and you're not getting any sort of depthness to it or whatever. It's just going on top of where it was. So that's like maybe even sometimes a flat color. Um, right, what other examples could we have? Right, what was the other material plan? So we had like sand, copper, gold, steel, moss, right, out and dirt. So, alright, so they have it in like Unreal, right? But isn't that so? You got to remember it's different, right? It's like a 2D thing, and it allows you to basically blend materials together, right? So that's like an alpha value, right? Here's you got this sort of like, you're seeing you're blending it. Now I think that might be blended based on height as well, right? That's the other thing we might, we're kind of achieving that with the ray marcher. right? And they have, yes, they probably have another map called like, it's like maybe a height map or a blend map or something like that. Where what's the height threshold that you blend the two materials? The layers basically, right? After all, it's a layering system, so you're picking like the thresholds of where they are. Whereas this is, we're ray marching into a volume. So when they have height information already, right, you just pick the earliest one. But when they trying to think if they don't, right, maybe what you can do instead is like, I was thinking maybe you can apply like offsets to some of these things. Like maybe you had like a gold material and mm, you wouldn't really mix golden with stuff though, would you really? Or maybe you might want to put it on. I was thinking like a moss layer you could do. Uh, Even on top of stone, the moss layer can go. Maybe dirt. If yeah. Hmm. Right, let's look at the game again. Something's off with this. Did we change the light intensity or something? Okay. Yeah, say if you wanted just to make it dirty, right? You want to come on and brush some dirtiness on it, right? Or maybe, right? So maybe, so you want to brush like some kind of brown, and that brown can vary, right, over something about the UV, right? As part of this sort of dirt overlay, if you will, the dirt layer that will just go on top, and so the dirt layer will go on top. And when you do the shading, it'll take the UV and be like, it will decide the color. Like how much of the, what brown does it want? A light brown or a dark brown, maybe. And then it would also decide whether or not to actually put the color there. Right, I could do a discard. So I think that could be one approach of layering. And the other approach, as we said, would be the ray march. But I wonder if you had the base layer of brick, if you just ray march against the brick, right? And then you ray march out that for the moss maybe. Or you just ray march against all of them and do a min. But that's where it gets a bit expensive, doesn't it? Maybe not though. Yeah, no, it would be cheaper to ray march against the bottom layer, then the moss layer after, but then escaping, being inside, then escaping the moss, and then yeah, it's a bit silly, really. That's more of an optimization, right? So I think we nailed it. So I think let's write this down. Material plan. Yeah, so I was thinking about looping up and doing some sort of additive blend between the materials, but that's not working now doing these 3D ray marching ones. So I think we want to do like layer materials, where there's two types. One is the ray marching, and two, it's like shading only. So ray marched, right? So if a material is ray marched, the one which it hits is the one where it takes the color from. There's no blending. So these would be so ray march against all the layers, all the material layers that support ray marching. The closest hit will be the material we shade with. Right, so we then shade I guess we'll do 2 shade with the closest hit ray march material layer, and then 3 apply the shading only material layers, e.g. like a dirt layer, maybe. Yeah, so sometimes you might have like an earth. You have like an earth material, maybe, and that's like, like soil. But then you have like a dirt layer where it's just something that goes on top, right? It gets to be painted on top. Maybe you have scratch layers as well. Where whatever it is, we have or maybe like a sand layer. Maybe you can brush sand over, right? Turn it into some blend of sand, or maybe call them the blend. Apply the blend. Right, so you might maybe call them geometry materials and blend materials. Something like that. So all the geometry, or maybe they're called the 3D. So yeah, the geometry material layers, they support ray marching. It's kind of a bit obvious actually from that sentence. So shade the closest hit geometry. Then apply the blend material layers. So maybe like a dirt or like a... Yeah, so if we're like tessellating these things, I wonder... So we're like tessellating the... what are we saying? We're tessellating these cubes, right? So the meshes that we do. So you could probably, we're storing like per face is going to have up to like 4 layers, I think. That's the plan. So maybe we can support like 2 ray marching layers and 2 2 blend layers, right? That could be quite cool. Or maybe you just support, 2 ray marching at most, and then the rest can be blend. That's the plan, right? Because the ray marching ones are expensive, and if we do any more than 2, it'll be kind of nuts. So 2 ray march, and the rest can be blend. Then you might have like a sand, you can like brush sand over it. Like imagine if you've got these nooks and crannies in here, and you could probably just, stick a bit of sand in there if you want. But the issue is, if you do that now, um, yeah, like imagine if you could say, like only apply this sand at this certain depth, only apply dirt at this certain depth, but then, and maybe there can be a bit of noise to it as well. So that the blend layers, you could probably have uh, blend layers support probably like, apply at, like a depth into the material. Not really by the ray though, is it? Hmm. Yeah, you want to have a way of saying, like, because the brick, you can tell if it's the border or the brick when you're inside some of the code. I wonder if you can take that and then sort of distill it down into like a Boolean and like pass that somewhere else to say like, oh, the blend layers are accepted. Right. And where would you stick that? Like on the triangle, like as part of the face information on the mesh, or hmm. So you've got the border. So you hit the border, you've got the border distance. You're like, okay, I've hit the border, but not the brick. And I want to put sand here, but not all the time. So there's some kind of noise of sand. So there'll be this sand blend material thing, and we'll have like, there'll be parameters on there like a frequency or something like that. And you can like, you know, based on the UV, you can, use some noise and be like sand, no sand. So then you also want to have a way to mask it out and say, you know what? So we've ray marched and then hit the brick. We're now outside of the brick, and somehow we've got to have a value pass from the ray marcher of the brick to the material, the blend materials later on. So maybe we can say for this pixel that we've hit, has the ray marcher told us the blend material can go here? So we could have the ray march materials could have different zones or something like that. So in the brick it would be the border zone and the brick zone, if you will. But then though maybe you could have edges as well. Edge could be another zone. So it's like, oh yeah, just put sand all around the edges. Maybe. Right? Or put dirt all around the edges. Or put maybe you can do like a mossy looking thing where it's just changing a normal maybe not. Yeah, because that's what you might really want, isn't it? Yeah, so you want to be like, so maybe you have different zones, right? So you know, like, what zone are we in within that material? And maybe that information can be passed to the next, to sort of the blend layers. So when you're sort of like maybe making a mesh, right? So okay, this is a brick wall. I'm coming along with a paintbrush and going, you know what, splash a little bit of sand here, and where I want this sand to go specifically is on zone 1, right? So when you've got these blend layers, you're saying like blend onto zone 1, please. But then you've maybe got to have a bit of uniform, like a like if we have two marchable layers, if you say did this moss with the brick and you hit the moss and the zone ones, yeah, this has 3 zones and this has 2 zones. It's not really that, you know, you've all got to agree on some kind of standard. If not, it's not going to be helpful if I sprinkle a bit of sand everywhere, is it? But maybe you say the sand only goes on the brick, but not the moss. Right, it gets a bit complicated as well, doesn't it? So when you're coming around doing the level, you might be like, well, you want to configure the brush and then be like, right, you're only going on the brick layer and you're going on zone 2. Right, but what happens if you want sand on both the moss and the brick? Right? So another approach we could take rather than saying zones is you could say you could pass a value which is either 0 or 1, or 0 to 1. And the material will return a 0 to 1 value. Now 0 will mean it's at the top and 1 will mean it's at the bottom. And then when you got the brush to do the sand or the dirt layer, you'll be like, so if you want it to go everywhere, you make it go to 1. But then if you want to make it go at the bottom, you move it down by one. Yeah, you could probably pick a min max. So you can make it only apply on the top or only apply on the bottom. Or all over. Yeah, so I think that might be the best approach. So then that way, and you want to make it apply on both the Raymarch object, both the Raymarch objects here. So you want to probably say, so the blend layer support apply at a min max. Right, so the Raymarch, the geometry material layers will output a 0 to 1 value. This is like, you know, how on top, or maybe it's a height value. Sort of height value. Yeah, so what would be really cool on the brick, you could say like, you could say that these little, these edge bits here are kind of like the lowest part. Maybe if you can figure that one out. And then these border parts are the second lowest part, and these top bits of the brick are the highest part. So as you sort of go and apply the sand or the dirt layer, it can get really nice in these sort of like crevices, if you will. And then it will come out into here. And you see, we've already got the AO, right? It's not that great, but it's there. So we've already kind of got this information. So it's possible to do that. That would be quite cool. Yeah, I think that's a good approach. So you have this sort of height value, and this is like basically where you paint. Yeah, so if you have the moss as well. Yeah, okay, I think that's good. So those support apply between a using the sort of height value from the Raymarch. That's pretty cool. That'd be super powerful. So it's not too complicated, and it's sort of should apply across multiple materials to some degree, quite nicely. So yeah, what was the other thing? So there will be like a noise, right? I think that will be controlled by the the blend materials will need a way. They will basically they will probably have some kind of noise. They will use noise to decide how much and how little to apply. So it's not everywhere, right? But it can be everywhere if you want, right? That's the point. Right, so that's going to be incredibly powerful. See, I wonder with the moss now, like, we've made this and that's okay. I wonder, like, since we've defined this idea of a blend material where it just changes stuff, is there a way, you know, you would have to Raymarch it to get the better look, right? To get the and with this you could Yeah, you can always like move it around and all that. Change the parameters such that it comes out just enough here anyway. Um, Although it's not going to be easy, right? If you come along again, it's like, right, I want to paint this to be brick. Right, this whole object is brick, right? I guess you could then say this whole object is moss, but then like getting it to go through, be blending right with the bricks is it's going to take some tweaking of like a bunch of parameters, and that's not necessarily going to be easy. But I guess you might do that sometimes anyway. Yeah, it all depends on the deepness of the brick and all this and that, and you might have to tweak both of them, and it might be a bit fiddly and annoying. So you should probably think about that. But maybe not. Maybe it's fine. It's worth considering. So yeah, because the other thing we thought was you can rainwash against the brick and then do the moss, but then you got to escape it, and it's only really a performance optimization when you know the second layer is expensive. So it's probably not that great. There's rainwash against both, right? Pick one. It's just a case of these properties. I don't really have any moss properties, but yeah, we had the spacing, the sort of the smoothness to blend the spheres or the ellipsoids together. And then we probably want to have some kind of like deepness as well, right? So there's not really that many parameters, but the spacing helps decide sort of how close they go to the edge of the box. Now, I guess you can have ways to sort of like move. There could be another parameter to sort of like squish it down, like bring it down, and that sort of thing. And yeah, I'm wondering if we've got sort of some non-square objects as well. That's another problem with it. So the other issue with this moss one is we have an non-square meshes. Like square meshes for bricks makes sense. Non-square we've got this following thing that we can do in the future. So it's just going to be used for brick walls anyway, so we can use sort of a couple of normals encoded into the mesh to remap it such that this is just following down the x-axis. Yeah, this is just following down the x-axis, and this would be the y, this would be the z. So that's all right, and the moss could follow that here. But I guess if you're going to make like a sphere of moss, we probably want to have ways to reject spheres if they're outside of a. So this is made up of tons of ellipsoids or spheres, right? That are stretched, and maybe if you're using this on just a I imagine if you make imagine if you make just like a being and you just go, okay, it's just make it a moss monster, right? So you paint over it. Could you probably reject some of those spheres based on whether if it's come out of the mesh or not? The way we do it with the bricks right now is to do it on the UV if you escape a box, right? If the UV goes less than -1 or positive, or more than +1, it's outside. But knowing if you're outside of so you have like a mesh, right? I don't know, just something like that. You're drawing this, how do you know when you've ray marched through the material and then ended up here? Right, from all these different angles. How do you know? Like, it's probably... Like you're doing it in material space anyway. So you end up like, you don't want to color the sphere here, which has the sort of moss, right? Outside. And you've also got problems of like, oh, this one's like halfway through. Do 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 do. You see, I kind of what I kind of see with the moss, to be honest, is I kind of see it as something that you're only really going to want to apply on top of something else like a brick, right? Or you or like a dirt, an earth shader, if you will, right? Soil or tree, right? So how could we? I know we've got this blend one, but how could we like? Maybe what we need is a... Yeah, maybe what we need instead. So maybe we can keep most of the code. But I think I got some ideas. So the idea would be that imagine if you ray march and hit this thing. So you got the ray march shader. So this is your base layer, and it is ray marchable. Maybe you can only have one of those. Then what you could do if you wanted to is add another one layer, and this layer could be a, you know, it could be like a moss layer or something like that, which offers some kind of, or maybe it's like a, maybe you want to add to your brick like some kind of like metals, like you know, you want to see like, I don't know, some gold pieces in there or something like that, but they stick out, right? So what you could do is now you've got this sort of like a detail layer. Maybe it's a detail layer. And the detail layer would be something like a moss. And what it still uses ray marching, but instead what it does is it only works if you're inside of one of the things, the SDF things, right? And its job is only to escape. And so what it's going to do is go across the ray the other way around and ray march out until it gets, and it'll do a times by 1.5 escape, and then it will ray march back down again and then hit the surface. And that way, this volume of you know, this volume of spheres and all that could just be applied on top of this. And that way, this doesn't really have to look kind of great when it's in a volume. It can have lots of spacing everywhere, but that's perfect because what you're trying to do is provide, you know, the odd little sphere which has which will then be used, oh crap, which will then be used as a thing which is ray marched out of. And what we could do is have a way to reject it, right? Say if like this actually is a combined sphere of sphere, and you realize, hang on a minute, it just has too much. And maybe that's the wrong one to look at. Say we're going here, and you go, well, that's not really a good thing, sorry, because you would hit the border. Yeah, okay. I think this is the idea. So, right. So this way we can sort of have the ray marching side of things, but deal with these problems where we don't want to have things be perfect rectangles everywhere, right? Um, so yeah, the question is, say if you want to make a monster looking guy that's just a moss man, right? You've modeled your mesh. So what you could say is you could have a material where it just brings in the model by a certain amount. How would you do that though? I wonder if you can have like an inset material basically, where it basically just like ray marches in um, by the same amount everywhere. Maybe just then that'll round everything, right? As like a roundness. But that could be possible. And then you could then apply these sort of like detail maps on top. But I wonder if that would be like a waste of a zero slot material, but maybe not. Yes, I think you'll have a zero slot material. Material plan. Right. Here's the new idea. Stemmed on this one. So layer materials. You have a slot 0. This is a special ray march. This would be known as the geometry material. There's only one. Okay. So and it can output unknown name. Yeah, it will output a 0 to 1 value for the height, okay? That can be used later for the detail one. Slot 1 will be like what's known as a detail layer, detail material. This can be like, so for instance, you know, e.g. this can be brick, right? The brick material. Then, so this one, yeah, so this we can sort of like, it really modifies the geometry and it has to fit perfect, right? So this would be, you know, designed. So you probably want to have very specialized, you know, very specialized material, specific, specifically for this model, right? That's what it would be. So for instance, the bricks, right? It's going to be like, oh, yeah, I want this many bricks on the X, this many bricks on the Y, and it's specifically for like that material. Maybe, yeah, maybe you might do like a fence or something as well. Yeah, maybe you can do like a fence one, I'm not sure. Yeah, that could be quite fun actually. Just all you just put up simple meshes. And then so this completely changes the geometry, right? You know, so it will completely change the geometry. Yeah, maybe you can do like tiles as well. So maybe like a brick material, maybe like a fence material, maybe a rather than like modeling every individual fence, you could probably do it as a shader, because when you zoom out from the camera, it might you might not need complicated mesh system then, maybe. Mm, I don't know. But yeah, let's put fence in there as just an example. We don't have to do it that way, but it's an option. Then you could have, what's another one that I was thinking about? It's like a fence or maybe like a wall, tile floors. Yeah, tiles, but also like the brick material is kind of that. So it could be like a tile thing, right? We could probably use that for tiles. Maybe like, okay. Yeah, completely change the geometry. What other things? Um, yeah, maybe you could do like a grass, right? But yeah, right. So the detail material is gonna also be able to modify, right? Be able to modify that sort of 0 to 1 height value as well. And the fun thing about this is it's, for adding, maybe that could be an inset. I think you can do that. So this will be specifically for like adding uh right, so geometry, change the geometry, usually a cuboid model. Maybe, requires to be a cuboid model, some of that, right? Requires a cuboid mesh, if you will, okay? Yep. Or yeah, usually needs a keyboard mesh. But the inset one could be like, so if I do a ray, the ray marching would just be -5 of the UV, and that way it should round everything, I think. Uh, so if you had like a mesh, you had that sort of like dun dun dun, and you had a geometry. So you had your ray and your UV. Obviously in UV space, or material space, we're going to call it. There could be a box like that. So -1 to +1. Then if your ray comes down here, like if you're saying your distance is, I wonder how much could you sort of get it to go, do like a rounded -5 around, right? And then you can add the moss layer on top. But that might be quite cool. I wonder how you could achieve that though. Or what do you do to achieve that? We'll think about that in just a minute. Let's finish writing these notes off. So we'll come back to that idea. So the detail material layer, so this may be moss layer, you'll be able to modify the height value, but you're essentially adding um, your ray marching out, okay, it's designed for, so it's probably like a general, adding So best for non-cuboid models to add like surface detail. So your examples are maybe like a moss, right? It's ray marched outwards. So how it works is if surface is inside the SDF, ray march out, ray march outward, then back to the surface and keep, right, and then shade, right. Then allow shade. If surface is outside the SDF, don't allow shade. Don't accept detail shading. Yeah, so that'd be pretty powerful. So you can have these sort of like volume sphere things, and yeah, that could be quite cool. So you have like a moss, maybe you have like a dirt or like a soil. Yeah, and that can work for like any. We can only have one of these, maybe. Yeah, only have one of these. Maybe we can do more in the future. I'm not sure though. Maybe like some kind of dirt, or maybe have like stones. You know, some sort of like like a stone layer, or maybe like or you have like pieces of gold and stuff. For some reason, just chunks of things that might work quite nicely. Hey there, welcome Gaio Buffet. Welcome. Thank you so much for the raid. Appreciate it. How are you guys doing? Hope you had a good stream. Welcome, streamers. We're just sorry, raiders. I'm the streamer. Yeah, we're just working on procedural materials. There's a custom engine written in C. We're doing something different when we're doing 3D materials at runtime. Ray marching into them is pretty expensive, but we've got ways we're going to make that better. We're just trying to figure out how can we make it really nice to sort of author materials and make it such that we could at runtime have many different materials that you can like paint down different layers on top of things and combine them, and just really leverage the fact they're procedural. Yeah, welcome guys. Downsy, how you doing? Yeah, we've got the moss done, and I was thinking like it probably won't work too great, but we've managed to figure out how to like make it work super great. So yeah, it's been mossed, I guess. Yes. Yeah, I guess so. I don't know. Maybe it's complex for Friday. Yeah, we're just figuring out rules around this layering system. I think it's gonna be pretty cool. So effectively, we've got an idea where we're gonna. Yeah, it's a bit much. um, so this brick essentially is just a box, right? We've got a lovely layered rendering system, so we use a visibility buffer. So we've got 4 layers of depth, information, and then in the shading pass, we go over this 4-layer visibility buffer, and we try and shade the first layer. If we miss, we go through and shade the layer behind. So when we hit this box, It's just a box. We ray march into it, and then we see if we procedurally run this brick shader code. So I think this will be called like a geometry material, where it basically you completely change the geometry of a mesh, and you're probably best just to keep that cuboid, like a 3D rectangle. And you can do stuff like a brick or maybe a fence, supports holes. And maybe I was thinking of this inset material, which is what most things would use, non-cuboid stuff would use. For non-cuboids to use detail. Thank you, appreciate it. Well, yeah, these could look way better, but we're trying to make it look better by doing super awesome, powerful things. But we've got to optimize it as well. It's dead slow. It's about 7 milliseconds for a shade. But I got ideas. We'll do the ray marching at core resolution, that sort of thing, and it's called a cone tracing pre-step, I think it's called. But yeah, we'll be doing one of those. Yeah, plain C. As the bot says, when you see, you see. If you don't see right now, get your C out, start programming in C, and then you'll see. Yep. Um, yeah, so then the detail layer is like this moss, and this is just a bunch of ellipsoids that are then smooth union together when we remarch. Just layers of different grids, right? A very coarse one, and then more high frequency grids of ellipsoids. All not even we're not doing a grid of 4, then 8, then 16. It's more like 3, 3, 7, 11, right? Just random numbers. Or maybe that's stuff we can't find it even. But anyways, see what I'm saying? Then such that they look irregular, and then we just do some other things to it. So these are the detail materials. So the idea is if you've ray marched and hit the brick, the idea is like, right, now you sample the detail layer. Am I inside one of the weird moss things? And the answer would be yes. So we ray march out, then ray march back to the surface. To ray march out, you have to like multiply it by 1.5 or something. Then ray march back, hit the surface, and then you can do your shading based on that instead. That's a detail layer. So this is like a mod. This will modify the geometry, right? Modifiers. So it modifies the geometry. And will override. Will take the shading from the geometry material if hit. Cool. And then your final slots 2 and 3, are the blend layers. So they just basically have a way of just changing color, basically. I think that's the idea. Like a dirt layer. E.g. dirt. Okay, this can maybe like soil or earth. I don't know. I feel like Phil for casual only managing to make simple isometric engine in C. That's fine. Like 3D and graphics programming is like super complicated. I wouldn't be too I wouldn't be too hard on yourself for that. Like graphics APIs are like stupidly complicated and it's a lot of effort. But these days, I guess you've got AI to help you sort of like learn the stuff. Because I think the biggest problem learning Vulkan is like, how do you understand the Vulkan spec? It's like stupidly, it's written in the most abstract way away from like how you use it. And the spec only makes sense once you understand it, you know? It's one of those things you're like, sorry. The spec only partially makes sense when you understand how to use it. There we go. It's difficult to read that spec. But yeah, maybe like or like they're like tint layers, right? So maybe you can add like yeah, like sand or something like that. Not rand, sand. Yeah, stuff like that, I think. This height will allow you to put it only on like in the crevices of the brick type of thing, or on the, but not on the top, or only on the top and not on the bottom. That'll be cool. Right, so I think this is great. I want to try and figure out next stream this guy. Right, how do we, if we have a non-square, like imagine if you just have a, you've modeled a man, and you want to make a moss man, but moss is a detail material, and you want to basically have a way to like shrink the mesh inward a bit such that you could then add the moss bits here, because the moss bits cannot sit outside the mesh, because if not it's going to look a bit funny. So you want to shrink the mesh in and then add the moss bits here, right? So if the ray hits here, then it can come out, and then yeah. Okay, so that's what we want to do next stream, is figure out that final thing, double check all of this, see if we've got any more ideas, because you know, have some ideas off stream, and then we'll want to try and properly implement it, and this would be awesome. Yeah, this would be so powerful. So then once we have this system in, we could probably add a few more of like these guys, and then we can start actually optimizing this. Awesome. In the meantime, guys, there's a Discord, if you come and chat and hang around. And yeah, if you're the code is also up on a GitLab. You can support the channel and get access to it to run on your own local machine. All the details are on the Ko-Fi. Yeah, thank you for everyone who's supporting the channel. Really appreciate you all. The next stream will be Sunday. Just check down underneath the stream. You see the schedule. Sundays, 7:30 p.m. GMT. I think it'll be GMT +1 because the clocks are changing. But yeah, Tuesday, Thursday, same time, and then next Friday as well at 2. But yeah, I'm going to spend time with the family now, guys. But yeah, have a good rest of your weekend. Hopefully see you on Sunday. If not, in a future one. But yeah, may the Lord bless you all, guys. And yeah, see you all soon. I'm frozen. Bye bye.